All right, it's 10:30. I guess we'll get started. Holy cow, it's still talkative. Yeah, it's quite chilly, not a fan. Golly. Yeah, it's just getting worse. I'm just waiting for people to stop talking. They're not stopping talking. So they're not stopping talking. Okie doke, let's get started. Let's see if that stops them. Okay, no, so I'll just start. So who's looked at either of the reviews? Okay, cool. Great way to start. Who's looked at your chapter 7 homework? Okay, cool. There is a bonus question on the exam. It is pretty much exactly one of the ones from chapter 7. And which one is it? Who knows? There's only one question on there that actually deals with it. I was trying to find another one, but there's only one question that deals with it. We talked about the actual concept last time. It's right at the very end. Wait, no, it wasn't. It was somewhere towards the middle, I think. Yeah, I think. Somewhere around there. It's at the end of 7.1. Okay, so obviously your exam is Thursday. No surprise there. It's going to cover the beginning of 5 up to 7.2, 7.3, and I don't know if there's 7.4 or not. Will be on exam 3. And your homework, I don't think it's due for 3 more weeks because we have a break next week. And I'm not going to post a video for you to watch because I'm going to enjoy my break. So we'll talk about that when we get back. What else? Nothing new. You're allowed a sheet of notes, is obvious, just like the first exam. You do not need to bring the tables. They're all attached on the exams. You can just rip them off if you want. I don't care. What else? Bring a calculator. You're obviously going to need that. That's pretty much it. All right, so are there any specific questions? Or I basically start from chapter 5 and tell you what I think you should know. Cool beans. Where's the markers at? Who keeps stealing these freaking things? I can't say what I want to say. Luckily, I had 2. Okay, so from the beginning of chapter 5. Cool, it's recording. What was chapter 5 about? Yeah, so you should probably know the definition of discrete probability distribution. Does anyone remember what it is? List all the possible outcomes a random variable could take on via a formula or just kind of like a table, and then the corresponding probabilities. So I would know probably the one that's in your notes, whatever it says there. I can't remember verbatim what it says, but that's the gist of it. Then associated to the probability distributions, we had two rules that make, I think your homework calls it valid probability distribution. Does anyone remember the two? Yeah, so that's one of them. So the sum of all the probabilities needs to add up to 1. And what's the other one? Yeah, all the probabilities need to be between 0 and 1, including 0 and 1. So I would probably know how to determine whether something is a valid probability distribution or find a value of some constant such that it makes it a valid probability distribution. I'm pretty sure there's 2 examples on the practice exams I gave. Let me see. Fair warning, the spring 2021 exam is easier than the other one. Okay, yeah. Question 1 on section 3 of the 2021 exam says find a constant, find the value C that makes this a valid probability distribution. So all you have to do is sum up all those probabilities and then find what C gives you a sum of 1. So know how to do that. Then the second thing we did, where the heck did I just put that? There it is finding the mean, variance, and standard deviation given a discrete probability distribution. So anyone remember how to do that? So you had some distribution of X and the corresponding probabilities. One, 6, 2, 6, 2. Yep. Making sure I did math right. So given something like that, say this was the K I wanted you to find. Then using that, you should be able to find the mean, or you can call it the expected value. And that's equal to the sum of each value that the random variable can take on times its corresponding probability. And then you sum all those up. So in this case, it would be 1 times 1 over 6 is 1 over 6, 2 times 2 over 6 is 4 over 6. 3 times 2 over 6 is 6 over 6. And the final one, 4 times 1 over 6 is 4 over 6. That is 15 over 6. Or you could just round that or simplify that to 2.5. So that part's the easy part. The next part, does anyone remember how to find the variance? So it's the expected value of X squared minus the expected value of X, that quantity squared. I guarantee you I will probably get at least 15 people that just give me this part as the variance. Happens every time. You have to remember to subtract off the expected value of X squared. So the first part of the question would say, find this. The next part would say, find the variance. All you need to do, you have this part right here, the expected value of X. You found that in the first part. All you need to find is this. How do you find that? So just like here, whenever you took each X and multiplied it by its corresponding probability and add them up, you're going to do the same thing, but instead of just being X, it'll be X squared. So it's the sum of the X squareds times their corresponding probabilities. Does that make sense? Then using that idea here, you have the first one, 1 squared times 1 over 6 is 1 over 6. 2 squared is 4 times 2 over 6, 8 over 6. 3 squared is 9 times 2 over 6 is 18 over 6. And the final one, 4 squared is 16 times 1 over 6 is 16 over 6. Oh my Lord, 9, 27, 43. Someone check that. I think that's right. Cool. Then this is the expected value of x squared. So that's this part here. Then to find the variance, you take this part here, 43 over 6, and you subtract off this part here, 15 over 6 squared. And if you do that, I have no idea what you get because I just made this up. 43 over 6 minus 15 over 6 squared. 11/12. So that would be the variance. And how would you find the standard deviation? Yeah, so let's take the square root of that. And the standard deviation of x would be the square root of 11 over 12. You could leave it as that, or you could simplify it. I don't care. Everyone okay with if I gave you a problem like that? How you would solve it? Cool. The next part. Know the conditions for a binomial experiment. Does anyone remember them? There are 4 different ones. So first, a set number of trials. You could also call it fixed. Second, anyone remember that one? Only 2 outcomes. And they are success and failure. Just like how this test will have 2 possible outcomes, either you pass or you don't. The third, the trials are independent. What does that mean? So what I get on one, say trial, is not going to affect what I get on the next. 4. Anyone remember that? Probability of success, P. Remains constant. Knows the full rules. So usually anything I write on the board is a pretty good idea to put on your note card. So fair warning. So I would expect maybe something like that on a true or false or multiple choice question. If you can't tell when I say that, it's usually on the exam. Okay, what else? Find the mean, variance, and standard deviation given a binomial experiment. Anyone remember that? That's actually really easy. So your homework gave you a crap ton of examples to do like that. If you have a set number of trials n, so n is the number of trials. In your homework, I think it also used like different students as examples or something like that. P is the probability of success. And Q, which is 1 minus P. So if this is the probability of success, obviously the opposite is the probability of failure. And you can find the mean, mu, by taking the number of trials times the probability of success. So the mean is NP. What was the formula for the variance? Yeah, NP1 minus P or NPQ. So it's basically the mean times the probability of failure. And then sigma is just the square root of sigma squared, or you can say the square root of NP times 1 minus P. Yeah, what's up? Before the 1 right here, Q equals. That's just another way to write 1 minus P. I think your textbook refers to it as Q. Everyone okay with that? That's pretty simple. As long as I give you N and P, you should be able to find Q. And then just using those formulas, you can find what I asked. What's up? Oh, between the probability distributions in this one. So in a discrete probability distribution, I'm going to list out, say, the possible outcomes I could take on and their associated probabilities. In this case, all I'm going to tell you is the number of trials and the probability of success. It's a little bit different setup. So the probability distribution part was what I first went over, where you list out all the possible outcomes and the corresponding probabilities. And in this case, we're dealing with a binomial experiment. So say in that example I gave, there was 4 outcomes. You could have 1, 2, 3, or 4. And their associated probabilities were listed below. I made them up. And then in this binomial experiment, there's only 2 outcomes. You're going to get success or failure. So there's 2 outcomes compared to 4. And also it satisfies these 4 conditions here. And if you have those 4 conditions satisfied, you can use the corresponding N, P, and Q to find the mean, variance, and standard deviation. Okay, I will look at it. What is the last step right here? This is just the square root of NP times 1 minus P. That's sigma, just the standard deviation. Then the last part we talked about in chapter 5 was using the binomial distribution table to calculate probabilities. And also I showed you how to plug them into the calculator. You want me to show you how to do that again? Okay. Let me find here. See if there's an example from one of the practice exams. I thought I put one in here. No, here's one. So this is fall 2021 or whatever it says. I think it's spring. Yeah, spring 2021. Number 14. For a binomial random variable x with n is 10 and p is 0.3, what is the probability of x equals 4? So I tell you n equals, what did I say, 10? P equals 0.3. And I want the probability that the random variable takes on value 4. Where's the table? Where did I put them? There. Then the way you do it on the table, I'll show it on the document camera real quick. and then I'll show you how to do that on a calculator. Here it is. This is on page 3 of your table packet. So you have 3 different areas. You have N, so the number of trials in this case, P, the probability of success, and little x, the value of interest you're looking at. In this case, we had N is 10. We were looking at X is 4 and P is 0.3. So if I intersect those, I get 0.200. That would be the probability that X is 4. What if I was interested in the probability of X being less than 4? What would I have to do? You'd have to take 1 minus the probability that X is greater than or equal to 4, and that's going to be a lot more numbers than the other one. If I said the probability that X is less than 4, not including 4, then it could take on 0, 1, 2, and 3. Then all you need to do is look up the probability that X equals 0, 1, 2, or 3, and add all those up. Yes. And I'm pretty sure on the practice 2022 or whatever it says, there is one that deals with it and is number 16. Should I actually look at that one? Because it's kind of tricky. Let's look at it. It says an upper division statistics class has 7 students. Assume all the students are independent of one another. There is a 75% attendance rate for the class. That means that P is 0.75. So the probability that a student attends class. The number of trials in this case is the number of students. Gosh dang it, I need to turn the camera around. People online, we're looking at number 16 on the practice 2022 exam. So N was 12, P was 0.75, and Q, which is just 1 minus P, is 0.25. First part, what is the probability that at least 10 students will be in class? So we're looking at the probability that X is greater than or equal to 10. Then what values can X take on in this case? So it's including 10. Probability that X equals 10, 11, all the way up to the maximum number of trials, which is 12. Then you find each of these probabilities in the table. And if you do that, the probability, we'll just write it this way, X equals 10 plus the probability that X equals 11 plus the probability that X equals 12. If you look up this one, it's 0.232. You look up this one, it's 0.127. And if you look up this one, it is 0.032. And you just take the sum of those, and you get 0.39. Yeah, there is. I will show you. In this case, the calculator will only give you one step at a time. So you'll input the number of trials, and then you'll input the probability of success, but it'll only take on one value each time. So I'll show you how to do it. Let me turn the camera back around. Then looking at that example, still number 16, go to second vars. That'll take you into distributions. Then you're going to go down to binom PDF. If you have an 83, I'll write out how to do it. So you hit binom PDF, you tell it the number of trials. In this case, it was 12. The probability of success was 0.75. And the first value we were looking at, X, was 10. Then hit paste. In this case, it'll go whenever you have an 83, N, comma, what did it go? N, comma, P, comma, and then the X value you're looking at, close the parentheses. Do you mind showing how number 17 on the practice exam goes? Yes, I can. Are you talking about the confidence interval one? Or are you talking about the one I'm doing right now? Okay. Then using that, you just hit enter and it'll tell you the probability of one of them. To find the probability that say it's 11, what you can do is go up here. I don't know if it does this on the 83 or not, but on the 84, you can scroll up, hit enter, and then just change this last number. Instead of having 0, just put 1. Second vars. And then it's option A. It's down at the bottom. No, you'll go down all the way to A. So whenever you go, so normal is at the top. Then just scroll down to there. Just use the arrow on the right hand side. Cool. And then you do the last thing for 12. And then all you do to add them up, how I do it on mine at least, is you go highlight the number, the probability for each of them. Then you just hit plus, and then another one, and then plus again. And look, you get the same thing. 0.39067. If you round to 3 decimal places, you get 0.39. If I give you like this, give you something like this on the exam, you can do either way. I don't care. So Bailey, you want me to go over number 7, or Kayleen, you want me to go over number 17 on spring 2022? If you want me to go over that one, I'll do that whenever we get to chapter 7, because that's the last thing we'll talk about. That's all for chapter 5. Any questions over that? Cool. Then on to 6. This is where the confusion begins. Let me turn this back around now, I guess. So the first thing I put on here is the properties of the normal distribution. So as it relates to the measures of central tendency, what do I mean by that? So if you have a normal distribution, it's unimodal. And what is the relationship between the 3 measures of central tendency that we talk about? Yeah, so the mean equals the median equals the mode. So say, for instance, I tell you, let's say X is normally distributed. with a mean of 10, what is the corresponding, or, say, what is the median? And in this case, it's just the same. I would probably give you something like a multiple choice where A was like 9, B 10, C 11, and D will make it crazy, put 100. If someone gives me an answer like of 100 on the exam, please don't. Everyone okay with that idea? Next thing, know the empirical rule for normally distributed random variables. So here, let's say we have a random variable X and it has a normal distribution. Say here is mu plus sigma, mu minus sigma, mu minus 2 sigma, mu plus 2 sigma. This is mu minus 3 sigma, and that's mu plus 3 sigma. Does anyone remember what the first one says? Yeah, so whenever you have within 1 standard deviation of the mean lies 68% of the data. Within 2 is what? Yeah, 95. Can anyone tell me what the exact number of standard deviations away from the mean that is guaranteed that 95% of the data will fall? We did it in chapter 7. Whenever we had a 95% confidence interval for the population mean, when we knew sigma, what was the corresponding critical value? Anyone remember? You'll probably need to know this. Positive and negative 1.96. I'll show you how to find the critical values in a second. So to make it easy, it just rounds to 2. And then within 3, it is 99.7. So you'd probably see something like this on a true or false question or a multiple choice question. Last semester, I gave it as a bonus question. And some people didn't know how to do it. And it was simple. Just use the empirical rule. Both of the things were 2 standard deviations away from the mean, so it's 95%. Or you can look at the z-scores for both of them, and then if you take the difference between the probabilities, you'll get the same thing. Yeah, drawing it out is the easiest way to figure it out. The next part, know how to find the probability of the form, the probability of a z-score greater than something, or the probability of a z-score less than something. In that case, what do I mean? I mean, find something like this. The probability of getting a z-score less than or equal to 2.11. Something like that. How would I do that? So I already give you the z-score, so you don't need to transform it into one. All you need to do is look in the standard normal table for 2.11 and find the associated probability to the left. Someone look it up and tell me what you get. Anyone? Yeah, correct. This is, oh, shoot. 0.9826. What if I wanted the probability of z being greater than 2.11? What's that? Yeah, 1 minus that. 1 minus this 0.9826, which is 0.0, nope, not 0, 0. But yeah, 0.174. I think that's right. Does anyone remember how to do the shading error, like whenever we did it in the notes? I said, here you have z distribution and you have the curve, and then you look at the area you're interested in. So say here's 2.11, and you shade the area you want. In this case, we're looking at the area to the left of it, so it'd be all of this over here. Top one. The bottom one would be this area on the right. So I'll put that in that color. So those are the easier ones. Then we looked at something of this form. So the probability of z being in between minus 1.20 and 0.50. How did you find that? So the first step was draw the curve, shade the region you're interested in. In that case, say minus 1.2 is here. And then 0.50 is probably right here. And we want the probability of getting a z-score between them. So that's the area in the middle there. And how would I find that? The easiest way to remember it is take the probability of z being less than the higher z-score and subtract it off from the probability of z being less than the lower. This would be equal to the probability of z being less than 0.50. Subtract off the probability of z being less than or equal to negative 1.20. That'll give you the area in the middle. Why do I have to subtract off this part here? This part here, the probability of z being less than that, will give me the area all the way from 0.5 to minus infinity. But I only want it up to minus 1.2, so I have to subtract off the area from minus 1.2 to minus infinity, which is that. I have no idea what those two probabilities are. Let's see. 0.5, 0.6915 minus z less than negative 1.2, 0.1151. So whatever that probability is, that difference between the two. Everyone okay with those two? Then the last thing that is going to get quite a bit of you. Say, for instance, I give you the probability of z being less than or equal to some unknown z-score equals, what's the example that's in your exam? It's greater than for the first one. Probability of z being greater than z naught is 0.8925. do you know how to find that Z naught? The easiest way is first draw what you want. So here you have the z-scores, normally distributed, and we're looking at the probability of z being greater than something is 0.89. So that means the area to the right of some unknown z-score is going to be 0.8925. So it's probably going to be somewhere around here, say. And this is z naught. And the area to the left of it is given 0.8925. But what does your standard normal distribution table only give you? The left. So what you need to do is find the left-hand area, and then you can find this. So to find the left-hand area, you just take 1 minus that, which is 0.1075. Then you have the area to the left is equal to this. And then you can find that corresponding probability in the table. So when do you do this compared to this? In this case, you don't know this part. So I'm telling you to find the probability of z being less than something and find that inside the table. And in this case, I'm telling you the area on the inside, and I want you to find the corresponding z-score. Do you see the difference there? One's the reverse of the other. Then if you look up that whatever it is, 1075, you get, where in the world did I just put it? Yeah, negative 1.24. This implies z naught is negative 1.2. So expect something similar to that. Just like on the practice exam, there's two different ones where it gives you the associated probability and it wants you to find the unknown z-score. Will PC values? No, we do not need to actually talk about those. So the skewness stuff, which we skipped in section 6.3, don't need to know. There was like 3 pages of notes that I skipped over. It was optional anyway, so it's on your homework. Next thing. Okay, we just went over that. How to find the z-score of a given data value. Everyone noted that? So if you have some random variable x that is distributed normal with some mean mu and standard deviation sigma, and you can find the z-score corresponding to some little value x by this. So z is equal to the value you're interested in, x, minus the mean mu divided by the standard deviation sigma. Does everyone remember that? You had to do it on your homework quite a bit. So that was the z-score corresponding to some particular data value. What if I wanted the z-score in particular for some sample mean? How would the formula change? So if we were looking at x bar, if we have the x is distributed normal with this implies that x bar, so the distribution of the sample means, is normal with the same mean mu, but a standard deviation of sigma over the square root of that. And in chapter 7, what did we call this? Anyone remember? It was on your homework. Or actually, it was on your homework in 6. The standard error of the mean. Then using the same idea here, you can find the z-score by taking the data value of interest, in this case, the sample mean, subtracting off the mean of the distribution, which is mu in this case. But the standard deviation for the distribution of the sample means is sigma over the square root of n. And I derived how actually that was in class. You want me to show you again or not? You don't need to know it. Okay, cool. It's probably something you would go over in stat 20, not 20, stat 3013 or stat 4013. Then, say for instance, you're looking at the probability of x being less than 45. I tell you the mean is 50 and the standard deviation is, say, 2. Then first you want to take this data value of interest here, turn it into a z-score using that. If you do that, you have z is equal to, so the value of interest is 45 minus the mean of 50 and divided by the standard deviation of 2. That's minus 2.50. Then this probability of x being less than 45 is the same as the probability of getting a z-score less than negative 2.50. And then you can find this in the standard normal table because it's already the area to the left, and you get whatever's in the table. Negative 2.50, 0.0062. And in particular, there's a couple of examples from both exams that you should probably look at. Which one is it? On the spring 2021, number 2 in the free response and number 3 in the free response. I would suggest you know to do those. Number 2 in the free response and number 3. And that's in the spring 2021. Then if you're looking at the other one, know how to do number 15. So in that case, it kind of gives you words on what it wants you to find. But if you can decipher the words and just write down what it's asking for, just like the probability of x being less than 45, it's a lot easier. Cool. In the last section, or the last chapter, I mean, chapter 7. This one is the hardest one up to here. We haven't hit the hardest chapter yet. Don't worry, it's coming. And I guarantee you I will get lots of emails over the homework because it's hard. Even last semester, I messed up on some of them because I used the wrong formula. Chapter 7, know how to identify the pieces of the confidence interval and calculate them. In general, we had the confidence interval was the form, the point estimate plus or minus the margin of error. And in this chapter, we discussed what the point estimate would be and how to find the corresponding margin of error. Then if we knew sigma, and we want to create a confidence interval for mu, then does anyone remember the formula? So the point estimate in this case is going to be something from the sample that estimates the population mean. And obviously that would be the sample mean, so X bar. And then plus or minus, if sigma is known, then we can use a critical Z value. And we can also use the population standard deviation divided by the square root of n. Then you can find X bar in the problem. You can find sigma in the problem. N will obviously be there, or you can see what it is based on the number of observations. The only part you need to find really is this, Z alpha over 2. Does anyone remember how to do that? Say, for instance, you want to do a 100 times 1 minus alpha percent confidence interval. Then say, for instance, here, to find the corresponding critical value, in the middle, you're going to have the confidence level. So in this case, say you wanted 95% confidence. Then in the middle here is going to be the area of 1 minus alpha. And what is alpha corresponding to 95% confidence? Move the decimal over 2 places to the left, and then take 1 minus that. So 1 minus 0.95 will give you the area in these two. I just said that completely wrong. 1 minus alpha is equal to 0.95, so that implies that alpha is 0.05. So then the area in between these two z-scores here, so this is say minus z alpha over 2. This is z alpha over 2. This area in the middle here is 95% or 0.95. Then the area remaining is what? 5. And it's going to be distributed evenly within these two tails here because they are the same number of standard deviations from the mean. One is just one below the mean and one is above. Then what is the area in each of these tails? Alpha over 2, so 0.05 over 2, which is 0.025. The easiest way to find these critical values is this is the z-score corresponding with area to the left of alpha over 2. That's how I remember it. You can remember it a different way. So here we had 1 minus alpha is in the middle, right? So then you have alpha in both of these added together, right? To give you the grand total of 1. And since these are both the same number of standard deviations away from the mean, the area to the left of this is going to be the same as the area to the right. So that means, say I let this area equal x, then this area is also equal to x. And when I add up these two areas, I get the value of alpha, which is 0.05, right? Then divide over and you get the area in each of them as alpha over 2 or 0.025. Does that make sense? Okay. So if I give you a confidence interval in the exam, I expect it to be a weird level of confidence. So something like 97. Then you have to find the corresponding z alpha over 2 value with 97% confidence, which isn't that hard. All you take is the 0.03 divided by 2. And that'll give you 0.015, and then you find the z-score corresponding with area to the left of 0.015. Did that make sense? Cool. Are there any questions over that so far? Neat. The next part, it says the relation between the confidence level and the significance level. That's just this right here. 100 times 1 minus alpha percent is the confidence level. That's all it means. And then I talked about what happens if I change alpha, what happens to the width of the interval. And does anyone remember what happens? As alpha increases, or let's say as alpha decreases. So that means as we're getting more and more confident. So as alpha decreases, so say for instance, we had 95%, which gives an alpha of 0.05. What is the alpha for 99%? Yeah, 0.01. So that means as alpha decreases, our confidence level goes up. So as alpha decreases, the confidence level goes up. And that is an ugly and. Let us put this. And the confidence interval gets wider. Then if I give you like 4 different things and I say which confidence level will give you the widest confidence interval, what would you choose out of all of them? You would choose the highest degree of confidence because it has the smallest alpha, which means it has the widest interval. And why is that? Anyone got a guess? As I decrease alpha, that means the area in this left tail here is getting what? Smaller and smaller. So that means it's going to the left more, right? That obviously means that this is getting more negative. So in this case, the corresponding z-score over here, the positive one, is getting larger and larger. Therefore, it's making this term here larger, and therefore giving you a wider interval. And then it also says, using the steps mentioned in class to carry out a confidence interval for the population mean, using either a critical Z or a critical T. When do you use which? So this was for if sigma is known. If sigma is unknown, then the formula becomes X bar plus or minus. Instead of a critical Z, it'll be a critical T. And in this case, we don't know sigma, so you estimate it with S and then divide that by the square root of that. So it's the same idea. It's just the critical value changed, and we estimated the standard deviation. In this case, it's a lot easier to find this value than it is the Z ones, because I'll tell you a certain level of confidence, and on the actual table, it literally says confidence intervals, and it tells you the levels up there. So all you do is look for the confidence level you want. Say I wanted 95% confidence. I tell you the sample size so you can find the degrees of freedom by doing what? So the degrees of freedom is equal to n minus 1. So then you could intersect the corresponding confidence interval level with the degrees of freedom to find the critical value in the table. You want me to show you how to do that? Cool. Okay, I guess I'll go over how I have it set up. How to find, use all the steps. So on, what year is this? Spring 2021, The final question number 4 in the free response section is how I would set something up. So the first part says find the sample mean. Or another way I could say is find the point estimate. In this case, this was pretty much right from the notes. This is whenever I made the test a little bit easier. But I got in trouble, so I had to make them harder. They're not much harder though. So if I take a random sample of 20 students at OSU and find their average GPA is 2.51 with a no, if you're able to use a critical Z or T. In this case, it says with a sample standard deviation. So what critical value we're going to use? That means sigma is unknown. So you use a critical T. And that'll be on the second part. So the first part says find the sample mean. If you cannot read off the sample mean in a problem that says the average, I don't know what I can teach you. So please know how to read that off. Then the second part says find the critical value. So if you're looking for a critical T, then it's easy. You just look at the confidence level. So in this case, it was 99. You intersect it with the degrees of freedom. 20 minus 1 is 19. And if you intersect those two, you get, what was it, 99? 2.861. Whenever I gave this exam, I got a lot of critical Z values. So they got this part wrong, this part wrong. Then they got this part wrong, which also gave them this part wrong. Was I nice enough to give them partial credit on these two parts? Yes. Will I? If it happens in here, we shall see. Just don't make that mistake. On the exam, it is clearly indicated whether I give you a sample standard deviation or population one. So you should know how to find the critical value associated. Then the third part, compute the standard error. So that's just sigma over the square root of n or s over the square root of n, depending on if I give you a sample or a population. Part D, compute the margin of error. That's just part B, the answer you get here, times the answer in part C, and that'll give you the answer here. Then for the final part, you take the answer you got in part A, so the point estimate, and then you subtract off and add the margin of error to that. So can you see why I do it in that way? You use these two parts to answer this part, and then you use this part and this part to answer that part. Should you know how to interpret the confidence interval? Yes. It will guaranteed be on there. Do you want me to look at, okay, so we'll look at number 17 since someone was asking about that earlier on your 2022 practice exam. Okay, so it says the length in minutes of a random selection of popular children's animated films are listed below. Assume the variable is normally distributed. Estimate the true mean length of all children's animated films with 95% confidence and interpret the interval you calculate. So in this case, this was someone else's exam from last semester. So I just took her exam and used it as a practice for mine because I made it kind of similar to hers. I give you what in this case? What are all these numbers here if you have the exam in front of you? Do you think those, whatever it is, 11 films make up all the possible children's films? The answer is no. Therefore, it is a sample. Then, what is the critical value we use? T. Then, you need to use this right here. I give you a sample, then you can find the sample mean, that part. And how would you do that? This is back to what we did in chapter 3. Just put it in a list in the calculator. It'll say the average at the top. That's that part. You can find the critical T value corresponding to the interval level. So in this case, it was 95% confidence and n equals 11. So that means the degrees of freedom is what? 11 minus 1 is 10. There we go. So intersect 10 with 95% confidence, and you get 2.228. Then you can also find the corresponding sample standard deviation from the one variable statistics on your calculator. It'll say SX. Just use that. Then all you do is use the formula to find it. In this case, I didn't write out all the steps because it wasn't written in that way on the exam. I just wrote it the shorthand way. You want me to show you how to remember to do the thing on the calculator? To do that, you go to Stat, Edit. Oh, look, they're already in here. 93, 83, 76, 92, 77, 81, 78, 100, 76, 75. So they're already all in there. Then hit second mode. That takes you back to the home screen. Then go Stat, Calculate, one variable statistics, and then tell it what list you want to do it on. In this case, I'm doing it on L1, so just hit L1, or if you do it on a different list, hit second, and then the number you did it on. Then go down to calculate. Do that, it'll tell you all you need. It says the sample mean X bar. It says the sample standard deviation SX. It tells you the sample size actually too. So the only thing it doesn't tell you in this is the critical T value, but you can find that using the confidence level and the degrees of freedom of 10. Is everyone okay up there? Then the interpretation, you should know how to do this. In this case, since we got a confidence interval of this, we are 95% confident the mean length of a children's animated film is between the lower limit and the upper limit. So the general form would be, gosh dang, I gotta keep running the chair. I think I gave this in class. It should be around the same as what I gave. So we are, in this case, put the confidence level here. So this would be something percent confident that in this case, this would be the parameter that we're trying to estimate is between the lower limit of the confidence interval, LL, and the upper limit of the confidence interval, UL. That's it. In this case, we were looking at the average duration of children's animated films. So we're looking at the mean animated film time for children. That's the parameter we're trying to estimate. Confidence level was 95. And the lower limit was whatever it was, and the upper limit was that. So you just plug those in to the corresponding places to get the interpretation. Is everyone okay with that? Okay, the last thing we will talk about before I let y'all go. Does anyone remember how to find the corresponding sample size to achieve some margin of error at some degree of confidence? Then let's look at this. So E is some given error you want to be certain within. Z alpha over 2 is the critical value, just like how we found whenever we created the confidence intervals. And then what else will we know? We will know sigma, the population standard deviation. So those, well, this one will be given, this one will be given. You'll have to find this based on the degree of confidence, what you should be able to do using the same ideas that I did earlier. Then you can find the minimum sample size by taking this Z alpha over 2 times, is it, yeah, sigma divided by E squared. Does everyone remember doing an example like that from your notes? Okay. There is one problem in your homework that deals with this. It is number 21. It says a pizza shop owner wishes to find the 99% confidence interval of the true mean cost of a large plain pizza. How large should the sample be if she wishes to be accurate within 16 cents? In that case, the error she wants to be within is what? E is 0.16. A previous study showed that the standard deviation of the price was 24 cents. That means sigma is 0.24. All you have to do is find the corresponding Z alpha over 2 for 99% confidence. Does anyone remember what it is? Or do I need to show you how to find it? I'll probably show you how to find it, because if I gave you something like this on the exam, it would be one that's not easily we talked about in class. So in the middle, the area between the lower critical value and the upper will be 99% or 0.99. The area and the tails will be what? 0.005. Because there's area of 0.01 remaining. So you have area 0.01 over 2 in each tail. Then you look for a Z-score right here that gives you the probability of Z being less than it is 0.005. Then if you get that critical value, I can't remember what it is. I think it's 2.58. Then Z alpha over 2 is 2.58. Then once you have these, you can plug it in there to find the corresponding value of N. And what happens if N is a decimal? What do you do? Round up. All right. Are there any questions before I let y'all go? All right. See y'all on Thursday.